Welcome to Stats with Chaz. I'm Dr. Charlie Collins. Today I will discuss basic descriptive statistics. Before we get into the content of this talk, however, I want to talk to you about two types of statistics, descriptive and inferential. Descriptive statistics are used to summarize one variable, as in univariate descriptive statistics, or summarize the relationship between two or more variables, as in multivariate descriptive statistics. Inferential statistics, on the other hand, are statistics used when we want to make generalizations about a population using a sample of that population. Throughout this series, I will discuss both descriptive and inferential statistics. But today, I focus solely on descriptive statistics. That said, today I will talk about how and when to calculate frequency tables, percentages, proportions, ratios, and rates. First, let's talk about when to use these forms of descriptive statistics. Many textbooks, including the ones I use for my course, will discuss using these basic descriptives for all three variable types, nominal, ordinal, and interval ratio. This is appropriate with the exception of the interval ratio type of variable. Here's why. What these textbooks do is take variables measured at the interval ratio level, which is the most precise measurement level, and break that precision down into less precise categories. Basically, what the textbooks do is take interval ratio variables and effectively turn them into ordinal type variables. Let's go over an example. Say I'm interested in measuring income in an online survey, so I ask the question, what was your gross income last year? Simple, right? If you're like me, you'd likely just state your gross income as close to the dollar amount as you could. If we asked 100 different people this question, we'd likely get about 100 different answers. Income is an interval ratio type of variable because it has a valid 0 point and can be theoretically broken down infinitely, and each interval is the same distance. In order to conduct the descriptive statistics we're covering today, we'd have to turn this variable into an ordinal type of variable by chunking or categorizing these responses. So instead of having 100 different individual responses, we'd place responses into categories such as 90,000 to 100,000, for example. Now instead of having 10 different responses, we now have 10 possible response categories. All this is to say that because your textbook likely discusses basic descriptive statistics that we are covering today as appropriate to the interval ratio type of variable, I'd argue that that's not necessarily true. Therefore, I will only cover descriptives for nominal and ordinal type of variables today. Now let's jump into it. First, let's identify nominal and ordinal type variables. Remember, these variables are those where responses are categorized in some way, meaning respondents will be clumped into categories. The difference between nominal and ordinal variables is that ordinal can be ranked in some way, such as you're in college, right? Freshman, sophomore, junior, senior, we can rank those. Using basic descriptives, we can start to make sense of those variables, or we can organize those variables. Let's use a running example of M&Ms to make sense of our nominal variable. Yes, I know this is statistics for social sciences, but M&Ms are a simple example. For these M&Ms, let's say each one M&M is a particular case. In the social sciences, this would usually be one person, so we can think of one M&M as one person. Let's also say that I'm interested in the color of M&Ms. M&Ms have a wide variety of colors, and so maybe I'm interested in the type of colors that come in my bag. So for us, this is our variable of interest, is the color of M&Ms. We then need to create the response categories that each M&M can fit into. Remember, with nominal variables, each case needs to be able to fit into one and only one response category. We can't forget to include blue M&Ms, for example. What basic descriptive statistics allows us to do is take raw data, or data in its most rudimentary form, as you see it now, and make sense of it. As you can see, we have 10 M&Ms. This is our N, or sample size. We can also create our variable M&M color. Each case is represented by one of the categories. So for example, we have red, blue, yellow, orange, and so forth. So each M&M is represented by one of those particular color categories. The first and most basic form of summarizing data is the frequency table, as you see here. Frequency tables take all cases and places them into their respective categories. As you can see here, I've rearranged the M&Ms by color of same category. I've added a column for the frequency. The number of this column represents the number of M&Ms of that particular color. So as you can see here, yellow has 3 in it. There is some mathematical notation here. The F stands for frequency of cases within a certain category, while the N stands for the total sample size or number of total cases. The frequency in N is very important as they inform the remainder of this discussion. Using this frequency table, I can now calculate things like percentages, proportions, ratios, and rates. To simplify our table, I'm going to remove the M&Ms and just keep the numbers for each category. I can now calculate each of the various statistics that we're going to talk about today. So let's start with percentages. Percentages allow us to standardize frequencies on a scale from 0% to 100%. So 0% to 100%. The formula for percent is as follows. So percent equals the frequency divided by the sample size times 100. If we are interested in the percentage of blue M&Ms in our sample of M&Ms, we would apply this formula. So what I'll go ahead and do here is go ahead and apply this formula. So the percent of blue M&Ms is the frequency of M&Ms, so this here, 2 divided by our total sample size, 10 times 100, which gives us 20%. So, and then that's our final number. So what we find is that our blue M&Ms make up 20% of all of our M&Ms in our sample here. Proportions are the same as percentages without multiplying by 100. I trust that you can figure that out, so we'll not review it here. Let's move on to ratios. Ratios allow us to compare relative sizes of different categories using this formula here. The F1 in the numerator stands for the frequency of the first category, and the F2, the denominator, stands for the frequency of the second category. For example, if we wanted to compare frequency of blue M&Ms to red M&Ms in our sample, we would use a ratio. For interpretability, it is often easier to have the category with the largest number in the numerator. We can then plug in the numbers and see what we get. So if we're interested in the ratio of blue M&Ms to red M&Ms, we'd plug in that formula. So ratio equals the frequency of the first category, so blue is 2, and the frequency of the second category, red, is 1. That equals a ratio of 2. Another way to put that is 2:1. So what this is telling us is that for every 1 red M&M in this pack of M&Ms, we should have 2 blue M&Ms. Finally, let's talk about rates. Rates are the actual number of occurrences of something divided by the possible number of occurrences times some standard unit. We typically hear of rates in terms of crime, such as homicide rates. Rates are also used in much larger populations, more than our 10 M&M sample here. So I'm going to move on to the example of home burglary rates. Let's say last year in a mid-sized city there were 120 home burglaries out of 237 homes. We want to know, out of every 100,000 homes, how many burglaries occur. So we'd use this number here. So we'd represent the number like this. So the number of occurrences is 120 divided by the total possible number, so that's our total household here, 237, times our standard unit. So we're looking at per 100,000 homes, and that's our standard unit. And after all the math is done, what we end up getting is 50.63. So the way that we would interpret this is that for every 100,000 homes in our mid-sized city, 50.63 burglaries occur. That is what I have for you today. Although I only covered nominal variables and didn't cover ordinal type variables, these same calculations can and should be applied for both. They function in the exact same way for both types of variables. By now, you should know how to calculate frequency tables, percentages, proportions, ratios, and rates. Thanks for watching Stats with Chaz. I'm Dr. Charlie Collins.